Okay. Can you please give a brief intro about yourself? More specifically, what currently technology stack you are using and what are the role and responsibility you have?
Yes, sir. So myself Ravinder, so total have 6 years of experience as a IT industry and as a data engineer more than 3 years. And my core skills are SQL, SQL, Snowflake, Informatica Power Center, AWS S3, and DBT, and Unix as well. And I started my career as a Informatica ETL developer, then moved to Snowflake developer later. Recently, I worked in Mass Mutual as a Snowflake data engineer. And I'm confident that my experience in building ETL pipelines and database solutions will be strong fit for this role. And I'm excited to this opportunity, and I look forward to contributing your team. And coming to the project, my current project is a PDE. PDE is nothing but a partner data exchange. It is a insurance data warehousing project. The client is an insurance company based in the United States, and they collect all the data from the source system and lands into the AWS S3 as a daily basis and a JSON as well as CSV files. From S3, we load the data into the Snowflake raw layer using Snowpipe for automated continuous data loading, and then we use DBT cloud transformation the data. Like we build the models like stage, intermediate, as well as mart layer. So the final mart layer is the final layer which is used for the star schema, and as well as which is used for the reporting purpose. Actually, we have followed the three environments: dev, test, as well as the production. So in this project, my roles and responsibilities are: I worked as a data engineer. When the data is loaded into AWS S3, then my work start from there only. We load the data into Snowflake by creating the storage integration as well as external stages, and load the data using copy command. In this process, we will create the file formats as well. For continuous data loading, we create Snowpipe to load the data into the Snowflake. If data has any errors, then we will create the error log table and insert the error recursion to those tables. For incremental model, then we will create tasks, merge statement, as well as streams as per the business requirement, and we take the data backups using zero copy cloning based on the required tables. In DBT, then we will create the models and models as well as tests to maintain the incremental loads and managing historical data. I'm also involved in requirement gathering and developing the ETL pipelines, and actually we are follow the agile methodology. In that agile methodology, every 2 weeks one sprint is there. On that time they are assigned the tickets. So based on the tickets, we will start to work on the priority items. And what work we have to do in the daily basis, then we will update in daily stand-up call as well. And I also involved in refinement, retrospective, as well as sprint planning meeting. So yeah, that's all about myself.
So we can say that 70% you are contributing like work, data pipeline, and Snowflake, performance tuning, and the 30% in some sort of Scrum Master, team lead kind of role, right?
But I'm a developer, not a team lead.
I said that responsibility.
Yeah.
That is just a designation.
Yeah.
Work with if you are involved in deciding that, then you just only what will be the features and all. If you taking a part of there, then you are not a developer. Developer means go to bucket, pick one task, and deliver it.
Yeah.
Can you give like a brief idea about the Snowflake architecture and how it different in compared to traditional data warehouse we had previously?
Snowflake architecture means in Snowflake architecture as a total 3 layers: storage layer, compute layer, as well as cloud service layer. Storage layer, this layer is used to store all that data physically. Like Snowflake stores data in its own cloud storage like AWS S3, GCP as well as Azure Blob Storage. So in this data is stored in compressed as well as micro partitions. So coming to the compute layer, it is a virtual data warehouse, and this process is used for the processing layer where the SQL queries are executed. So multi-warehouse can query the same. It can be like it can be perform the DML operations especially. So whatever the logics we have there now, so most of the logics we have to apply in virtual warehouse only. So coming to the cloud service layer, this is the brain of the Snowflake, and it handle authentication, query optimization, as well as metadata management, security purpose. So when you run a query, the cloud services layer process it creates the execution plan and coordinate the storage and compute. I think this layer it runs 24 by class automatically, 24 by 7 automatically.
Okay. And what is the concept in terms of Snowflake virtual warehouse and how it help in saving cost or optimize the performance? Feature like auto suspend and auto resume.
Yeah. Virtual warehouse is nothing but it's in a Snowflake warehouse is a virtual compute cluster used to execute queries like which perform DML operations, right? So warehouse are, we can increase the sizes from X small to up to 6x large. Then and each size increases the double and computing power as well, and they can be set to the auto suspense as well as auto resume. It can be happened in virtual warehouse only, and you can create multiple warehouses running simultaneously. For suppose one ETL pipeline, one user for the one user, and another one ETL pipeline for user for the one BI developer, and that part is what can I say? Um, whichever it is used now, it can be billed for that particular warehouse only. So the term, virtual warehouse is a warehouse means same thing in Snowflake as well. So it's called a virtual warehouse because it does not connect to the physical hardware, and Snowflake spins up cloud computing on demand as well.
How micro partition is different than traditional partitions we used to have, and how we can create a micro partition?
Micro partitions are the fundamental storage unit in the data warehouse. So it can be stored in columnar format as a compressed file, and when you load the data into Snowflake now, so Snowflake divides the data automatically, and that data into small compressed files called a micro partitions, and each micro partition is typically stored 50 to 500 MB in size as a compressed file, compressed data. And
so you're saying that we can't create it, it's auto got created by Snowflake micro partition, right?
Sorry?
We are not creating a micro partition.
Yes, it's automatically divided. Yeah.
Okay. And what are the table types we have in a Snowflake?
Total 3 types: permanent, stage, as well as transient, temporary.
What is the what is the transient table types use cases?
Transient. Most of the in Snowflake used in transient only. Like when we are using this transient, I means mostly when we are using the in DBT now. So then that time it's transient tables we are used. So like. it is not stored any data physically.
Okay. What is a zero copy cloning and what is a practical use case?
Zero copy cloning.
Yes.
Yeah, zero copy cloning is used to instant of copy the like data tables as well as schema without storing the, I mean, instead of duplicate data without copying the creating the those data into the instant copy of a database schemas or tables without physically copying the data. It works to Snowflake. It works in using Snowflake metadata as well as so cloning. So it's very fast and storage efficient. We mainly use it for the dev, QA and UAT environment. For test purpose, we can mainly use it for this zero copy cloning.
How Snowflake handle concurrency?
Concurrency, I mean, this one cluster queries, right? Concurrency queries, right?
Yeah, queries. Yeah, go ahead with the queries.
I mean, clusters. Concurrency means like multiple users or queries. Multiple users or queries can run at the same time without affecting each other. So Snowflake handle concurrency using virtual warehouse and automatic resource management.
Yeah, that is true. That is a definition of concurrency.
Yeah.
How Snowflake handle it? How it maintaining concurrency?
Maintaining concurrency clusters.
Like how it allow you to multiple users run the query at the same time without affecting the performance. What architecture, how it's handled, like might be in a 2 second before there was a one user was using, might be in another second it be 100 million user using the same database. How Snowflake handle this change of concurrency?
Yeah, Snowflake can auto scale and add additional clusters to the.
That is the answer I was looking for.
Yeah,
Okay,
yeah.
got it. Suppose we have even with the large warehouse object we selected, right? And so there is no issue of RAM, memory. Already we choose the large object. Still, we found that there is performance of query is very poor. What could be the possible root cause of it?
I mean, you say performance issue in Snowflake, right? So first we need to check the, I mean, lots of steps are there to improve the performance in Snowflake. So even if you use large warehouse now, data warehouse now, so query performance can query performance can still it's slow due to the proper query design as well as data issues. And one common issue is large table scans happening because of missing filters and improper joins as well as no partition pruning, and another reason can be is a data skew, mainly data skew and excessive shuffling error and high concurrent workloads causing query queuing, and sometimes they are designed very purely like clustering too many micro partitions as well as our complex views also impact performance. Then we usually check the query profile execution plans and byte scans and catching behavior to identify the root cause before executing the query.
Okay. What is this pruning?
Partition pruning.
Yes. How it is different than cluster? Compare with the clustering.
Partition pruning means if skips the reduce, it is also a performance tuning feature in the Snowflake. Snowflake reducing the amount of data scanned during the query execution. Snowflake automatically uses the micro partition metadata like min and max values. So skip unnecessary partitions. So these unnecessary skip the what are the skipped scanning partitions, right? So those are called as a partition pruning. Sorry, pruning.
Yeah. Okay. Have you used clustered by?
Oh yeah, yeah.
My question is when we would avoid it. When we should not go for cluster by.
Cluster byte.
By.
Cluster by. Small
Yes.
table, small table. If the table is very small now, so then we do not use as a cluster by.
Okay. Uh, any metadata or view you are using for analyze the query performance?
Any metadata or view?
Or view of Snowflake that you are used to analyze the query performance.
Materialized view.
Okay. And what you are looking in materialized view to debug the why the queries are performing correctly.
So materialized view is nothing but it's great. So yes, we use query profile extensively in Snowflake to analyze the query performance and identify the bottlenecks. And we are also used account usage as well as information schema and information schema views for the monitoring warehouses like usage and query history. Mostly we check for the query history, warehouse load history, and table storage metrics views. So using these views, then we identify the long running queries and high scan operations and warehouse overutilizations. And based on the analysis, then we applied the clustering keys and optimizing the joins and improve the partition pruning over the performance.
How would you implement incremental load efficiently? As you said that you already be implementing, working on incremental loads, right?
Yeah.
In a pipeline. How you are doing it in Snowflake?
By using streams and tasks, we can implementing this incremental load.
And if I would say that as you are doing it with stream and plus task, and might be you can able to do it with DBT or any ETL tool, how it is different? What is the difference between if we go for streams plus task and for any ETL tool for orchestration?
Yeah, so we handle incremental loads mainly using streams and tasks, major statements in and DBT incremental models like streams is capture the insert, I mean DML operations and from the source tables as a CDC data. So then tasks are task is a scheduler object. Then it is used to it is used to run the SQL queries as well as stored procedures on the schedule time. So Snowflake has a native scheduler, that is the task. By using the cron expression, we can schedule the task. So in DBT incremental model mainly handle the transformation level incremental processing, and inside the Snowflake tables, streams and tasks are the more real time, more used in the CDC tracking for the automatic pipeline executions in Snowflake. And in DBT we use incremental materialization and with condition like date as well as process only the data. So in streams, automatically capture the row level changes where DBT depends on the business logic and filters. Mostly we use Airflow for the orchestration and streams and tasks for the CDC and DBT transformation and modeling.
Any benefit in terms of cost?
I mean, like, I can't understand your question.
Like which one is more cost efficient? If we go with the DBT, okay, let it be this question.
Okay. DBT incremental model are cheaper because they run only during the scheduled transformation jobs. So streams and tasks can increase the compute usage. So it runs frequently near processing. So compared to the Snowflake, then DBT incremental is the cheaper.
Got it. Am I not clearly like audible to you or what? Because it's frequently, I'm getting my answer, but the second part. That's why I thought.
I'm able to hear properly your voice, Sagar.
Okay, perfect. Can you explain the seeds?
Seeds?
Yes, seeds in DBT.
Yeah. So seeds are nothing but like it's a files it is stored the seeds are used to load small static reference data from the CSV files in a Snowflake table, and mostly we use seeds for the country codes, status mapping.
Yeah. And what about the snapshot?
Snapshots are mainly used for the it is tracking the data like type 2 SCD type 2. So
got it. So it's just like a benchmark to compare once it's
mainly it's tracking the historical data in a dimension table similar to the SCD type 2. So they mainly help to the maintain the old and new record versions whenever your source data change. We use snapshots for the for suppose we use snapshots for the customer as policy and account history. So they are start to tracking in Snowflake. DBT automatically manages the columns like DBT valid from or DBT valid to for the control version controls.
Can you give me the one micro I'm sure that you already created a many macros, right?
Macros, yeah. Macros.
Okay. Just give me the one macro example why you created that.
Yeah, macros is nothing but it is a piece of SQL code when the business is.
Forget about the definition.
Okay.
Explain your one macros why you created.
We create the reusable DBT macros mainly for the insurance validations like audit logic. Example, what can I say? So in insurance, lots of claims are there. So like data, claims data as well as customer data and mobile number tracking from the multiple source system. It get from the multiple source system. Instead of writing masking logic, every DBT model we create one reusable macro for the sensitive data masking. These macros we can check for the column type and mask values except the last 4 digits of the authorized reporting. They'll to maintain the HIPAA and complaints and reduce the repeated SQL code across many models. Like if business logic changes now, so we update the macros once it reflects in the everywhere automatically.
How do you manage DBT environments in depth and broad? DBT environments, right?
Okay.
You have a 3 environment, AIMS and broad, right?
Yeah.
how you are handling the environment level variables in your DBT. DBT need to get deployed in staging, then production. How you are creating it?
Yeah. In DBT, we manage to separate environments like dev, QA, and production. Now, so using different target profiles and schemas. So each environment add separate Snowflake databases and warehouses and RBACs as well. So we use Git branches. So by using the GitHub actions, we use the CI/CD deployments into the production environments. Specific variables like variable like database names and warehouse details like were merged through the profiles. So .em or .yaml. So .yaml and DBT variables before production deployment. We validate models using DBT test snapshot as well as incremental run checks.
How would you refactor a slow DBT model?
Slow DBT model.
Slow. Your DBT model is slow. How you will refactor it?
Yes, we are working on a refactoring slow DBT models to improve the performance and reducing the execution time. And first we analyze the query profile and identify the heavy joins and unnecessary CTs as well as to complete the whole table, and then we will finalize the data volume which table is. It will take lots of time. We change the full refresh models into the incremental model using unique incremental model using unique keys and loading timestamps, and also remove the repeated transformations, and by creating reusable stage models and macros finally. And we optimize we optimize warehouse usage and clustering keys and filtering the source data. And source data it is those allow the user to reduce the scans as well as logs also.
Have you heard about or used anti-joins?
Empty.
Anti, anti. Anti-join.
Anti-join.
Forgot it.
I mean, I heard, but we are not yet using.
Absolutely fine. We can't use everything whatever in market, right?
Yeah.
So it's absolutely.
I'm here.
Okay. You know about that fact and dimension, right?
Yeah.
Have you heard about that scenario about the late arriving data?
Late arriving data, yeah, we can.
How you will handle it if you have a scenario of late arriving data? For example, your fact data is coming before the dimension.
Okay.
How you will handle this?
Yeah, late arrived data means source records are received after expecting processing window or batch completion. So in Snowflake, we handle this using incremental logic with watermark or updated timestamp columns. So for example, dimension table, especially ACD type 2 na, so we check the effective date carefully and before updating the history record. Sometimes we process previous partitions or rerun affected incremental batches to maintain the data and make data consistency, and by using the streams, tasks, and DBT incremental model. So those are the help to capture the process and miss records automatically.
Okay. Can you explain me what is the CDC?
CDC.
Yes.
CDC is nothing but a change data capture. So it.
Any real-time an example from your project?
Means it is identify the change of records like insert, updates, deletes from the source system. So instead of full records, full data for every time, then it will capture the only process. CDC help us only incremental changes improve the performance. And yes, in my project too, we are working on the CDC for the claims and policy data processing and source system continuously updated with the claim status as well as the payment mode as well as policy details through the data. We are using the Snowflake streams. We capture only the change of records instead of loading full tables every time. Then yeah.
Yep. Ravinder, I'm done from my side. Do you have any question?
No, Sagar. This project is includes what are the technologies main?
What I asked about, like SQL, DBT, and Snowflake, basically. And if someone have a exposure in a reporting or in latest cloud AI services, then it's just nice to have. But majorly, we are looking for someone very good in a Snowflake and DBT.
Yeah. So,
okay. Anything else?
This project is for which domain?
BFSI.
BFSI. Okay, I have a very good experience on that one. Okay. Yeah. Thank you, Sagar. Nice talking to you.
Good day. Same.
Yeah. Bye.
Table text चलेगा.
Table here.
ये जिसका हम table से अपना सीजन बेस करके करेक्ट आंसर टेबल उस टेबल का पास करके table text